right, today we're starting section 3.5, Basic Matrix Operations. First of all, a few definitions. 1. A matrix is a rectangular arrangement of numbers in rows and columns. The dimensions of a matrix always goes rows by columns, so you'd say M by N. The dimensions, think about it, these are rows, okay? And columns are going to go the long way like this. Like I always think of Washington, D.C., there's a lot of buildings with columns. That's how I remember what columns are. The elements of a matrix are the numbers that are actually in the matrix. And two matrices are equal if their dimensions are the same and the elements in corresponding positions are equal. Let's perform the operation. Sometimes things are not possible. If you're going to add matrices, they have to have the same dimensions. So let's start out by naming what the dimensions of both of these are. Now if you look at the first one, there's 2 rows, so this is going to be a 2 by, and then there's 1, 2, 3 columns, so this is a 2 by 3. And this second matrix is also a 2 by 3. Now that we know that both of these are 2 by 3 matrices, I can go ahead and do this addition. What you need to do is add the corresponding spots. Like this spot right here is row 1, column 1. So I'm going to take row 1, column 1 in both of these. It'd be -2 plus -3. So in this spot, I'd put -5. Then when we move over, we're in row 1, column 2, so I go to 5 plus 1 is 6. Then we move over to the last spot in row 1, 11 plus -5 is +6. Now we're going to move down to row 2. 4 plus -2 is 2. Next spot over, -6 plus -8 is -14. And then the last spot in row 2, 8 plus 4 is 12. So now I've done the addition of two matrices. Now let's do subtraction. Think about subtraction when we were doing that before just with integers. Subtraction is the same as adding the opposite. So what I would like you to do is get into the habit when you're doing matrices to go ahead and change the subtraction to addition. And just like with integers, I'm going to take this whole matrix after the what was the subtraction sign, and I have to change all the signs. Okay, so I'm going to change all the signs. 0 obviously stays 0. 5 becomes negative. 14 becomes positive. Okay. Now some people are going to say, can't I just go ahead and do the subtraction in my head? Yes, you can. And if you can do that, that's fine. I would say that there is a very common mistake where people forget to change the sign, so their numbers come out wrong in the end. So if you get into the habit of changing subtraction to addition and adding the opposite, I think it will be helpful. So now we add -4 plus -2 is -6. 0 plus -2 is -2. By the way, I didn't say this, I should go back. What are the dimensions of this matrix? We have 1, 2, 3 rows, and this time we only have 1, 2 columns. This one is also 3 rows by 2 columns, so these are both 3 by 2s, so we can go ahead and do the addition here. I should have started with that. 7 plus 3 is 10. -2 plus 0 is -2. -3 plus -5 is -8. 1 plus 14 is +15. So there would be the subtraction of those two matrices. What about this one? If we look at the dimensions, here there's 1 row and there's 2 columns. So this would be a 1 by 2. This one has 2 rows and 1 column. These dimensions are not exactly the same. We cannot do this addition. So this would be not possible. Okay, so if it's not possible, sometimes we just need to write not possible. Now let's talk about a scalar. When we're talking about matrix algebra, a scalar is a real number. And scalar multiplication is when you multiply each element in the matrix by the scalar. So if I'm going to perform the operation that they gave us right here, basically what I'm doing, -4 is the scalar. I'm just going to multiply all of these elements in this matrix by -4. So that's going to leave me with -8, +4, +12 in the first row. Now we take the second row times -4. That's going to be +28, -24, and -4. And moving down to the third row, if I multiply by -4, I'd have +8, 0, and +20. So that would be the scalar multiplication of that matrix. Now let's put it all together. I'm going to take this first 3 times the first matrix, that's scalar multiplication, so I'm just going to do that scalar multiplication real quick, and it's going to give me 12, -3, -9, -15. Now I'm going to bring down the other matrix, so it'd be plus the -2, -2, 0, 6. Now since both of those matrices have the same dimensions, I'm going to do matrix addition. 12 plus -2 is 10. Moving over, -3 plus -2 is -5. Then we'd have -9 plus 0 is -9. And -15 plus 6 is also -9. So that would be the scalar multiplication with addition put together. This is straight out of your book. When we're dealing with matrices, there are properties that work for matrices. We can do the associative property. So if you have 3 matrices added together, we could change how we associate them, okay, as long as all you're doing is adding them. Commutative, you can switch them around if all you're doing is addition. You can also do distributive with a scalar. If this k was a scalar, I could take k times a, and then I could take k times b, and then I could add them together. Or I could take the 2 matrices put together first and then do the scalar. But distributive property does work, and it also works for subtraction. So you could do the scalar multiplication first and then subtract the 2 matrices that are left over. And that concludes section 3.5.